Quadratic word problems that we're talking about today. I'll go through an example, maybe two, which will help you with your homework and how to handle these in general. One of the reasons that quadratics are important, one of the many reasons, is because they model. Come on, Bell. Why 5? Do we need 5 bells? Really? Like 1 or 2 can't do that? Quadratics model how objects fly through the air. Things that move and that are affected by gravity follow a parabola. I mean, every time you've thrown a ball, you've understood that it doesn't actually follow like a semicircle. It follows a parabolic form of some sort, and it's best modeled by quadratics. So this formula here actually models how time and distance can be calculated with these parabolas. When you see these V naughts, this VO is read as V naught, N-A-U-G-H-T, like nothing. And that's kind of a classic English way of saying nothing. This stands for your initial velocity, how fast an object was launched or thrown to start with. Y naught stands for the initial height. T in this case stands for time. You can use T's or X's, it doesn't really matter, T's or X's. And then A is the acceleration due to gravity. That means how fast gravity is pulling things down to the ground. And on Earth, it's going to be a constant rate, more or less, but it can change based on which planets you're on and how much gravity there is. But this general formula here is how we set up these equations. So keeping that in mind, if I do this problem down here, it says the acceleration due to gravity when working with feet is negative 32 feet per second squared. That's our A value. Our A value is negative 32. If a model rocket is launched from the ground with an initial velocity of 200 feet per second, that's our V naught, write the equation that can model the height of the ball over time. Well, since it was launched from the ground, we know that our starting height is 0. So now I can write the equation y equals 1/2 times negative 32 t squared plus 200t plus 0, which simplifies to y equals negative 16 t squared plus 200t. Now the next thing that we're told to do is to graph this, but actually graphing this, I'm going to scroll down now, graphing this is much easier if you can find a few things, like find your vertex and find your y-intercepts. So I'm actually going to start with finding those things. The vertex. To find the vertex, I do x equals negative b over 2a, and that gives me the AOS, axis symmetry. Well, negative b over 2a is negative 200 over negative 32, which is something not too messy, actually. Negative 200 divided by negative 32, 6.25. The AOS of this graph is at 6.25. At this point, I'm going to type into my y equals menu this equation. Negative 16x squared plus 200x. I don't really care how the graph looks right now. I'm going to go to my table. In my table, I'm going to type in, I'm going to make this so I can put in points of my own choosing. I go to my table and I type in 6.25. It comes out with 625. So the vertex is at the point 6.25, 625. Well, since I know that's the highest point my graph is going to reach, I know that I want this graph here to count up to at least 625. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 steps. So if I count by 10s, that's not quite high enough because that only goes, or I'm sorry, by 20s, that's not high enough. If I count by hundreds, it goes to 1400. If I count by 25, so if I do 14 times 25, nope, not high enough. I'm going to count by 50s. I'm going to count by 50s. So I get rid of all of this. Sometimes you have to just take a second to figure out what you want to count by. So I go 0, 100, 200, 300, 400, 500, 600, 700. And now each box stands for 50. This is also, the highest point is 6.25, so if I count by ones out here, 2, 4, 6, 8, 10, 12, 14, and that should cover enough x distance. Now I can plot the point. 6.25 comma 625 would be about here. Now it's a bit of an estimation, but I think that's pretty good. Now I can use my table to just find other points. If I go to my table and I plug in like 0, 1, 2, 3, 4, I have the point 0, 0 obviously because we started on the ground. I have the point 1, 184, we're going to put about here. 2, 336 is right about here. 3, 456, just above that line. 4, 544. 5, 600, nice and simple. I don't really need to plug in a 6 because I'm so close already, but 6 is going to be 624. It's basically right there. Then I'll go 7, 8, 9, 10. Seven is 616. 8 is 576. 9 is 504. 10 is 400. 11, 264. 264 is going to be right about here. And 1296. Go a little bit more. I think 13 should put me at negative at this point. Yeah, 13 is negative, which means that I'm somewhere below the ground, which doesn't make any sense, obviously, because we would have hit the ground and stopped. And then that gives me this curve to try and follow as best I can. And that was done very poorly, so maybe I'll try again. I don't like that either. Whatever, I'll live with it. Actually, let me see if my computer can do this well for me. It's going to be tough to make this work, but I'm going to try. No. Sorry, I'm wasting your time. I'm just going to graph on the wrong, call it good. I'm going to go crazy. A little bit crazy. Okay, here's my graph. And for the record, now that we've got this window all figured out, you know, the window from here to here, now that we have that all figured out, we could also do the window on here the exact same. My x's are going from 0 to 14, and they're counting by ones. My y's are going from 0 to 700, and they're counting by 50s. And I get the same thing. So you can always take your window that you found on your paper and put it on your graph as well. So here's the part B. Part C, how can we find how high the rocket is after 6 seconds? Well, 6 seconds is time, and time is going to be 6. So I really just do f of 6. And I can look at my graph, but at this point f of 6 was so imprecise that I really want to go back to my calculator and find f of 6 here. If I go back to my table and plug in a 6, yeah, 624. It was 624 feet high. That's how high it was after 6 seconds. I'm going to find when the rocket is 250 feet high. Well, 250 feet high is the y value, or the f of x value. So I set up this equation, 250 equals negative 16t squared plus 200t. I'm going to solve this for t. Now, because this is a quadratic with two variables, I'm going to subtract 250 from both sides and do the quadratic formula. 0 equals negative 16t squared plus 200t minus 250. On my fancy calculator that I use personally, I've got the quadratic formula programmed into it. Not on this one, but my real one. If you want to do that, that is worthwhile, and I'd be happy to help you figure out how to do that. But for now, I'm just going to do negative b plus square root of b squared minus 4 times a times c. Close that parenthesis 1, 2, 3 times. Nope, just 2 times is all I need. Doesn't mean I need 2. And divide that by 2 times a. Well, a is still negative 16. I get 1.4. So t comes out to 1.4. But you have to remember something. The ball or the rocket, or whatever this thing is going to hit 250 feet on the way up, but then again on the way down. It happens twice. That's why these quadratics have 2 solutions. It's going up and it's going down. So I press second enter to pull up my previous equation. Go back and change this plus here to a minus. The second time it happens is at 11.1 seconds. The rocket is 250 feet high at 1.4 seconds and at 11.1 seconds. Next, how can we find when the rocket reaches its maximum height, and how can we find how high that height is? There's 2 questions here. There's a when, and there's a how high. There's a time, and there's a height. Well, luckily, we've already found this. This is just a vertex. The x-coordinate of the vertex was 6.25, which is really t in this case. It was 6.25 seconds. The y value of the vertex was 625, I believe. Is that right? Yep, 625. That's the height. It went 625 feet high, and it reached that height at 6.25 seconds. That's 2 components, x and y, which in this case was time and was height. When does the rocket hit the ground? We are trying to find roots, or we are trying to find intercepts. One way we can do this is plugging in a 0 here instead of 250. To hit the ground, the height must be 0. I can do the quadratic formula again. Or, and I do that, I'll get 2 solutions. If I pull up my calculator and I do second enter, I pull up my previous equation and change the c value, which was negative 250, just change it to a 0. That's really all it was. It was really just a 0. I get 12.5 as one of my solutions. And I get, change this minus to a plus, 0, obviously. Of course it hit the ground at 0 seconds, because the rocket started on the ground, right? Started here, and then here this should have been at 12.5, so my graph's a little bit off, but that's how you figure that out. Vertex, x-intercepts, y-intercepts, quadratic formula, it's all the same sort of stuff. Thank you.